Itchy scalp and dandruff driving you crazy? Try this Dr. Ville shampoo. Flake-free and fresh.
Restore scalp balance. Tap below to buy.
Itchy scalp and dandruff driving you crazy? Try this Dr. Ville shampoo. Flake-free and fresh.
Restore scalp balance. Tap below to buy.
Buy now.
Restore scalp balance. Tap below to buy.
Buy now. Try this Dr. Ville shampoo. Flake-free and fresh.
Restore scalp balance. Tap below to buy.
Buy now.
Iggy, my daughter came to me in a panic over dinner last night. She's in the public sector too, and she saw the GovTech news. She wants to know if this is 90 over people let go.
It's unusual.
Okay, that's reassuring. So, what do I actually tell my daughter?
Tell her the odds of this specific pattern hitting her role are low. unless her agency is going through the same kind of function shift. But so what does this mean for you more broadly? Even a job
Watch this. I ask for an entire scraping pipeline in one sentence. The AI reads my rules, writes its own implementation prompt, and asks me, is this good to execute? I say yes, and it builds the whole thing. That's the video. So let me show you how to set it up. What if your agent didn't just build your feature, but wrote the prompt for it too? Be honest. How many times have you gone back and forth with AI on the same feature and still not gotten what you wanted? You know, that's the recommended value, and make sure to copy it in case we need to use it later. For now, click deploy, and is set to 15, which is likely a blocker because it depends on the Vercel plan. So the hobby plan hourly limit, which is most likely what you have, limits the cron jobs to once per day. So the cron expressions that would run more frequently will fail during deployment. Our schedule is set to hourly, and I can run that because I have a Vercel Pro plan. But for you, you might need to switch it over to every 12 hours. So it's asking us which Vercel plan is the project deployed on. Since I'm on Pro, I will select Pro. And again, to fix it for you, you can select Hobby. Considering that I'm on the Pro plan, everything on the code side is correct and shipped. We just have to wait a bit. Confirm registration, not observability. So go to Settings, Cron Jobs. If we go here, once again, you can search for cron jobs under Settings, not observability, and you can see that our API cron pipeline had been added here. Then verify its production deployment. That seems good to me. Set the cron secret, which we already have, and then run a quick manual test. Then wait for the next 15, which means that everything is working and that in about half an hour from now, I'll be able to get all the new articles scraped and analyzed right here on my landing page. So take a second to look at what you've built. SKU News scrapes real news from multiple sources, analyzes each story for sentiment and AI estimated framing, and shows it all in a clean, authenticated UI, and even refreshes itself every hour, deployed and running on its own. That's a real production-style product. But this is just the starting line. Everything we build is a foundation that you can keep building on. And the way you'd add to it is by using the same loop that we've used the whole time. You can further let signed-in users bookmark or save articles. The clerk and Supabase combo should make that super simple. You can add search, topic filters, or trending session.
Principles.md file with the exact structure I use myself, all linked below. Pro tip, open up each one of the MD files, go to File, Download, Markdown to make sure you're downloading in the right format. After downloading the files, drop the Claude MD and Memory MD files into your root folder, then create a 00_resources folder, and within this folder, move the voice principles.md file over. We can now go back to Cowork and select the parent folder we just created right here, Cowork OS. And after we open it, we click Always Allow. And we can even go ahead and star this so that Cowork defaults to this folder every time we start a new session. Just so we're 100% clear, the Claude.md file is the instruction manual that tells Cowork how to behave. The memory.md file is like a notepad that stores things Cowork should remember between sessions. And the root resources folder contains detailed knowledge that Cowork only loads when it needs to. Pro tip, install the free app Obsidian, and under Open folder as Vault, we can click Open and locate the Cowork OS folder we just created. Click Open, and now we can simply view the ClaudeMD and memory.md files in a more readable format. Don't worry, you don't have to learn how to use Obsidian. I don't know how to use Obsidian. We're just using it to read the markdown files. Clicking into the root claude.md file, there are three things I want to highlight here. First, under memory system, right up top, there's a line that says, at the start of every session, read memory.md before responding. And there's a rule after that that says, when I say remember this, write the information to memory.md. And these two sentences are why Cowork has persistent memory. Second, the routing map section contains a table that tells Cowork which workstation folder to load for which type of task. We haven't built any workstations yet, but when we do later on this video, this is where they'll be all listed. And third, references. These are pointers to files in our root 00 resources folder that Cowork only reads when it needs to. This is one of the ways to keep token usage low. Moving on to the memory.md file, we have two sections here, active projects and memory. Starting with the memory section, this is where Cowork will automatically add entries when you tell it to remember something. For example, in a new session, I type, current events are distracting everyone from the E-list. Remember that. And Cowork will add that to the root memory file as a new entry. First, you can see that under the memory section, Cowork has added a new entry right here. And to test this out, we can even start a new session and ask, what did I say about distractions recently? And after a few seconds, which I will fast forward, Cowork will draw from its memory and answer correctly. Back in our memory.md file, the active project section works the same way. Just tell Cowork about projects you're actively working on, and I'll add both the project and the progress of that project right here. Moving on to the resources folder, we can now start building out our voice principles file. So assuming you watched my first Cowork video and you connected your Cowork to Gmail via connectors right here, what you want to do is go ahead and grab this prompt template that I've linked below. It's the same link. You want to paste this, option 1, Gmail connected prompt template into a new session within Cowork. Press enter. And what this does is Cowork is now going to extract writing patterns from your last 30 sent emails to build your voice profile. If you haven't connected Gmail, find 5 writing samples that you like, could be yours or someone else's, and simply paste the prompt template under option 2, no Gmail connected, and it does the same thing. After a few minutes, Cowork will tell you that the voice principles file has been updated, and we can click into the voice principles markdown file to see all the patterns it has extracted. For example, I apparently talk in a warm, direct, and professional tone of voice without being stiff. Cowork will just add more entries as it learns more about your preferences. And just for reference, my actual voice principles file is actually over 150 lines long. By the way, the reason I keep saying root ClaudeMD, root MemoryMD, and root resources folder is because each workstation below that root level gets their own ClaudeMD resources folder and MemoryMD. But before we get to workstations, everything we built today revolves around one important concept, relevant context, is how surfacing implied context is the key to getting better AI outputs. Implied context is the stuff you inherently know, but forget to tell the AI every time. Your writing style, your active projects, how you like your email structured. That's the whole point of Claude MD and Memory MD. They remember it for you, so Cowork always has the full picture. All right, so we've covered the root level, and going one level down is workstations. And these are basically areas of your life, each with its own Claude.md file, memory.md file, and resources folder. Broadly speaking, there are two types of workstations. Universal workstations handle things you do across every area of your life. Email is the clearest example. You email your team, your accountant, your sponsors, your friends, so the rules for how you write email apply across multiple workstations. Dedicated workstations handle one specific area of your life. For example, within personal finances, I manage my spending, my savings, and my tax deadlines. Now let's start by creating a universal workstation, Email HQ. I first grab the prompt template from the same link below where you downloaded the starter templates and go to the Email HQ video prompt. And then you're going to copy this, head on back to your Claude Cowork and paste it in and click enter. And we're just going to let this run for a minute or two. And I'm going to fast forward this next part. All right, now that it's done, let's walk through what the prompt just did. First, this step one, it triggered a rule inside our root Claude MD. So let's just open that up. Under our root Claude MD, we have a creating new workstations section that say, whenever I ask for a new workstation, create a subfolder with that name and add a Claude MD, Memory MD, and empty resources folder inside. Then step two, the prompt's own instructions kick in. Similar to the previous example, it basically says to search my Gmail sent folder for the last 4 weeks of emails, then analyze and extract only email-specific patterns that aren't covered by my root voice principles, for example, like greeting and sign-offs, right? And once you have those patterns, add with sharing my credit card statements with Cowork. If you're not, don't. It's literally that simple. All right, it's done. Let's walk through what happened. First, similar to the Email HQ example, the prompt created a personal finances workstation folder along with a personal finances Claude MD and memory.md and an empty resources folder inside. Second, Cowork read every transaction across my statements, broke down the spending by category, and built a master spending tracker spreadsheet inside my personal finances resources folder right here. And we can click into preview. We can see that it created 4 tabs: transactions, yearly summary, monthly summary, and category taxonomy. And let's say Cowork made a few classification mistakes. For example, this one, Canva, should not be freelancer and contractors. It should be software and subscription, right? That's totally fine because after I correct Cowork once, telling it, hey, Canva's actually subscriptions and software, it will remember that for next time, and next month's expenses will be categorized correctly. Pro tip, Obsidian only indexes markdown files, so the Excel file is invisible in the sidebar here, even though it obviously exists on disk, right? So just remember that the Cowork OS folder is a single source of truth when it comes to saved documents. Now, after building almost 30 workstations, I can tell you it's best to start slow. Build 2 or 3 workstations out, get used to how the Claude MD and Memory MD files all interact and work together, and only build new workstations when the need comes up. One thing to note before we move on, under my dedicated workstations, I also have project subfolders. For example, under my housing workstation, I have a project for refinancing my mortgage. Under travel, I have one project folder for every planned trip this year. Under speaking engagements, I have a project for an upcoming corporate workshop. Each project gets its own Claude MD, Memory MD, and resource.
Operating systems are very complicated, but also very important to understand if you're building software. Basically, every piece of software that a software engineer is writing relies on the abstractions that an OS provides. So let's walk through and talk about some of these. The first one being the layers of execution and the difference between user mode and kernel mode. Let's yet again start with some abstractions, because just like $1 from $2 and put the result in $3. But this is approximately what CPUs do, right? There's, differences between Intel, but this is essentially the language that the CPU, higher level language, right? You might be writing JavaScript or Python or TypeScript. Ultimately, again, that is getting those are oftentimes running in like a virtual machine or a runtime environment, and that runtime environment was built and ultimately is just executing a bunch of instructions on your CPU. So the problem here is that this is very simplistic, right? If I have a CPU, and we'll pretend that this is just a single core CPU, that will keep all of these conversations simpler. In this setup, we would like to have an abstraction that isn't just, hey, I have a CPU and it takes one instruction after another, right? That is literally what a CPU does. But as a programmer, and you as a software engineer, and our AI companions don't want to have to just think about, I have to dump a big sequence of instructions onto this CPU to get it to do what I want. We want to be able to do things like open our computers up, and we want to be able to think in terms of operating system kernel. And then above that, we have the kernel. Okay, so hardware, kernel abstracts this. How exactly does the abstraction work? This is something we'll talk about a little bit more, but a lot of this happens through system calls, where there's an interface that the kernel essentially provides you with a set of nice and convenient functions that you call, it switches into kernel mode, and then it handles the actual interfacing with the hardware. But we'll get to that in a second. Okay, so our hardware and then our kernel, and like I said, the interface to access the kernel are through system calls. We'll look at more of these in a second. And then there's sort of an interesting relationship between the next two layers, because we have system libraries, just say system libs, and these are things that are not executing in the core of the operating system kernel, but they're essentially convenience libraries, often come with your operating system. They're often written in C or C++, that are typically, we think about these as sort of convenience wrappers over system calls in some cases, and in some cases they don't do anything related to the kernel or the lower levels of the operating system. And then finally, we have user space. So why did I draw this box almost a little bit oddly shaped? User space, this is where when you write a program in Rust, in TypeScript, whatever you're executing, maybe it's single process, maybe it spawns many processes, maybe it's single thread RAM somewhere, and then be able to pipe them into OBS and then be able to project them as a virtual camera.
So, Greg, I've just been wondering, I've been hearing so much talk recently about harnesses. What is a harness?
So when we talk about harness, we're talking about an agentic harness. That begs the question, what is an agent? My favorite is Simon Willison's definition. An agent is an LLM with tools running in a loop to accomplish a goal. The main thing a large language model does is next token prediction. You feed it a bunch of tokens or a bunch of words, and it does fancy autocomplete to figure out what should complete that sentence or statement or string of text. We came up with function calling. And so the idea here was that you could sort of prime the LLM and you could say, hey, I have these functions that you can run. The function signature looks like this. You pass it these parameters. Those functions could do all sorts of things, right? But generally speaking, what you're doing is using these functions or tools to go grab context that's external to the LLM, and then to feed that context into the context of your conversation with the LLM so that it can augment its response. That's the tool portion. How do we give the LLM access to information that's not baked into its training data? And then there's this portion of running in a loop, right? So it's not just a one-for-one. There's some mechanism there where we are programmatically evaluating the output of the large language model to determine, is it done? Has it reached the goal? And if it's not, then we feed it more instructions programmatically, and then we have it just run in that loop. Those are the portions of like, what is an agent? And my definition of an agentic harness, the harness is everything after the LLM. The harness is, how do you give it tools? The harness is, what programming do you have that's running it in the loop? What programming do you have that is evaluating the output of the LLM to determine if it completed its task or not? And all of that infrastructure, which doesn't have to be a lot, but that is the agentic harness. All that stuff you put around an LLM to turn it into an agent.
That makes so much sense, because I had been thinking of the harness as like, it's like the IDE, or it's like what's running your agent, but it sounds like your definition is lower level of that.
If you think about the most popular agentic harnesses today, so like a Claude Code or an Antigravity or a Codex, right? There are different interfaces that you can use to interact with that harness. So I think it's really interesting that if you decouple the harness from the interface, you're saying the important piece here is how we control the logic and the behavior of the LLM. And then you can sort of like swap in, what interface does the user prefer?
Totally, and every use case.
And every use case, absolutely. There's probably actually a lot of use cases where you don't even need a user interface. You just need a programmatic interface to the agent, like an autonomous agent. And then